In this episode, we prove that the cell can remain stable in conditions that are almost double what typical lithium-ion cells can operate in. These conditions are 80 degrees Celsius and 100 degrees Celsius.
Donut Lab won't stop until they truly convince people that their solid-state battery is a real miracle. Every 2 weeks, a new test is released, and this time they've just announced the results of a second independent battery test, in which the cells were heated to 100 degrees Celsius and discharged. The truth is that most conventional lithium-ion pouch cells suffer severe degradation and face serious overheating risks. At this temperature, the batteries can explode or catch fire. Yet Donut Lab's solid-state battery reportedly shows an almost absurd increase in capacity. We understand that some people just want the headline up front, so we'll give it now. And then anyone interested can watch the rest of the video, where we explain why we believe Donut Lab's solid-state batteries still hold many unresolved mysteries. So is this the scam of the century or a revolution? Previously, in the first independent test, Donut Lab demonstrated that their battery could charge from 0 to 80% in just 5 minutes. The result was genuinely impressive, but it also sparked plenty of controversy. In the second independent test, the Finnish company aimed to prove the battery's performance under high-temperature conditions. As before, the second test was conducted by VTT. VTT is Finland's largest state-owned and state-controlled applied research organization and technology research center. It's important to note that VTT only tested what Donut Lab provided and followed Donut Lab's testing plan exactly. Their role was not to prove or disprove anything. They simply carried out a service according to the client's request. So what does this new VTT test actually show? VTT tested a Donut Lab battery labeled DL2 with a nominal capacity of 26 ampere-hours and a nominal energy content of 94 watt-hours. To put that into perspective, a typical iPhone battery only has a capacity of about 3 to 4 ampere-hours. That means Donut Lab's 26 ampere-hour battery is roughly 7 to 8 times larger than the battery in your phone. The Donut battery was placed inside a climate chamber, and this time VTT applied a 2.4 kilogram steel weight on top of the battery to create mechanical pressure. Meanwhile, a temperature sensor was positioned underneath the battery, an essential detail for high-temperature testing. First, the battery was kept in the climate chamber at 20 degrees Celsius and allowed to stabilize for 1 hour. It was then charged with a constant current of 24 amps until the voltage reached 4.15 volts. After reaching this level, charging continued at a constant voltage of 4.15 volts until the current dropped to 1.2 amps. In the first test run, after charging was completed and the battery rested for 1 hour, it was discharged at a constant current of 14 amps until the voltage fell to 2.7 volts. Finally, the results of this process showed a battery capacity of 24.9 ampere-hours. We know some of you might feel a bit overwhelmed by the numbers, but essentially, this first test step simply shows that the battery was charged and discharged under standard conditions to determine its actual capacity, and the measured result was 24.9 ampere-hours. So what does this actually mean? It's easy to see that the 24.9 ampere-hour charge-discharge result measured at 20 degrees Celsius in the climate chamber is about 4% lower than the stated nominal capacity of 26 ampere-hours. And this is where things start to get interesting. After the battery was fully charged using the standard procedure, the temperature inside the test chamber was raised to 80 degrees Celsius and held there for 2 hours. At this temperature, the battery was discharged at the same 24 amp rate and delivered 27.5 ampere-hours, reaching 110.5% of its room temperature capacity and exceeding the 24.9 ampere-hours measured at 20 degrees Celsius. Finally, at a temperature of 100 degrees Celsius, using a discharge rate of 12 amps, the battery delivered 27.6 ampere-hours, corresponding to 107.1% of the reference capacity at the same discharge current. Yeah, basically, the 100 degrees Celsius test was conducted at a 0.5 C rate, only half the rate of the 80 degrees Celsius test. So the two figures cannot be directly compared. What is quite interesting is why they did not test at 1 C at 100 degrees Celsius. We do not fully understand this. If you have an explanation, please let us know in the comments below. However, there is one notable issue after discharging at 100 degrees Celsius. VTT observed that the battery pouch had lost its vacuum. The battery was still functional and charged normally afterward, but the outgassing suggests that either the packaging or the battery's chemistry generated gas at that extremely high temperature. Based on what we have found, Standard pouch packaging typically uses a polyolefin adhesive to bond the aluminum layers to the inner polypropylene layer. This type of adhesive melts at around 85 degrees Celsius. Testing at 100 degrees Celsius may have compromised it. Initially, the company claimed that the battery operates safely across a temperature range from -30 degrees Celsius to 100 degrees Celsius while retaining over 99% of its capacity. VTT's actual data shows that the battery exceeds its room temperature capacity even at elevated temperatures, which is even better than the claim regarding absolute discharge performance. However, VTT did not test at -30 degrees Celsius, and the loss of vacuum in the pouch at 100 degrees Celsius raises questions about long-term durability under such extreme conditions. That said, we should also be fair and give Donut Lab the credit it deserves. 2 independent VTT test reports within a 2-week period, both confirming specific claims, demonstrate a level of transparency that exceeds that of most battery startups we have seen. The high-temperature results are particularly significant. Maintaining and even increasing capacity at 80 degrees Celsius and 100 degrees Celsius is something conventional lithium-ion batteries simply cannot do. As we mentioned earlier, conventional lithium-ion batteries are very sensitive to temperature, and their maximum operating temperature typically falls in the 60 to 70 degrees Celsius range. At higher temperatures, the risk of battery damage increases, reducing lifespan. In addition, high temperatures can accelerate internal reactions and, in the worst case, significantly increase the risk of thermal runaway. So with this second test, it essentially shows that the donut battery has a fundamentally different structure because it does not contain a flammable liquid electrolyte, allowing for a higher maximum operating temperature. However, there is another caveat in the documentation that we need to clarify. VTT did not verify whether the tested battery was truly a lithium-free solid-state battery, as with the first report. The second report states that VTT conducted tests on an energy storage device provided by the customer and identified by the customer as a solid-state battery. After the first test results were published, some experts publicly challenged the claim that the battery operates without lithium. Many pointed out that the charge curves and additional data suggest it may, in fact, be a lithium-ion battery. After 2 rounds of testing, the 2 most notable claims have still not been independently verified by any third party. For any type of battery, energy density is always the most important concern.
With Donut battery, we set a new baseline, 400 watt-hours per kilogram.
The energy density of the Donut battery is claimed by its chief executive officer to be 400 watt-hours per kilogram. However, the chairman of S-Volt Energy, a company that has been manufacturing electric vehicle batteries at large scale with a strong technical foundation and real-world commercialization experience, Yang Hongjin believes that Donut Lab's solid-state battery is essentially a scam, marketed far beyond what current technology is actually capable of. A report by VTT lists a battery with a capacity of 26 ampere-hours at a nominal voltage of 3.6 volts, which equals 94 watt-hours. To achieve an energy density of 400 watt-hours per kilogram, the battery would need to weigh around 235 grams. The VTT report does not include the battery's weight, so this claim cannot be verified based on the available data. To be fair, an energy density figure of 400 watt-hours per kilogram sounds somewhat more plausible in light of similar claims recently coming out of China. Companies such as Cattle and BYD have also expressed confidence that they will achieve solid-state batteries with energy densities in the same range. What makes Donut Lab's claim controversial is that it says its battery can reach such a high energy density without using lithium. This is where skepticism peaks. Around 70% of the batteries used worldwide today contain lithium. Lithium is not favored simply because it is familiar, but because it is close to an absolute optimal choice. It is the lightest metal and also has the highest electrochemical potential. Once lithium is ruled out, the field immediately becomes crowded with heavier candidates such as sodium or zinc, materials that struggle to reach even 200 watt-hours per kilogram, let alone exceed it. This is where the well-known battery paradox begins. The higher the energy density, the greater the cost usually paid in cycle life, as materials repeatedly expand and contract during charge and discharge. And if the goal is ultra-fast charging, the risks of rapid temperature rise and the formation of dendrites, metallic needles that can pierce the battery and cause fires, loom close behind. 400 watt-hours per kilogram, a full charge in 5 minutes, and a lifespan of up to 100,000 cycles. That sounds like claiming you have just built a car that can travel at 500 miles per hour, gets 1,000 miles per gallon, and still runs smoothly for 1 million years without ever needing an oil change. Donut Lab claims that its battery can operate for 100,000 charge-discharge cycles, The 100,000 cycle claim is really strange. For an electric vehicle, if you charge once a week, that is just 520 cycles in 10 years of ownership. How could they claim 100,000 cycles unless they actually tested it? And why would they not stop testing at 10,000 cycles? 10,000 cycles would already be a really impressive number, far beyond what anyone would need in their lifetime. Even if you charge once a day, 10,000 cycles corresponds to about 27 years. And it takes literally 10 times longer to test to 100,000 cycles. It is not outside the realm of possibility that they did this, but it is still a little strange. For comparison, leading commercial lithium-ion batteries typically achieve only 1,000 to 5,000 cycles. Solid-state batteries that have been independently validated by Factorial Energy show a cycle life of just over 600 cycles. Donut Labs' claim goes far beyond anything that has been demonstrated in the industry. Proving such performance through independent testing would take an enormous amount of time at any reasonable testing rate. Low-temperature performance at -30 degrees Celsius. Donut Lab claims that its battery can retain more than 99% of its capacity at -30 degrees Celsius. However, the high-temperature tests conducted by VTT did not include low-temperature testing. On the cost front, Donut Lab claims its batteries will be cheaper than lithium-ion batteries because they use 100% green and abundant materials. So far, however, no independent cost analysis has been published. Meanwhile, the largest solid-state battery developers today, Toyota, Samsung SDI, CATL, and BYD, are all targeting initial production of their own solid-state battery cells in 2027 or later. None of them claims to have a production-ready cell that meets all of Donut Lab's specifications simultaneously. CEO Marco Lettimacchi has staked his reputation on delivering these battery cells to Verge Motorcycles in Q1 2026, a deadline that is now only weeks away. This electric motorcycle has been marketed with a range of up to 370 miles and the ability to charge to 80% in under 10 minutes. For many years, battery researchers have viewed solid-state batteries as the solution to most, if not all, of the limitations facing current battery technologies, by replacing liquid electrolytes with solid ones. Solid-state batteries promise a wide range of advantages: significantly reduced range anxiety, ultra-fast charging, stable operation in extreme weather conditions, and, most importantly, greatly improved safety due to their non-flammable nature. In theory, a fully solid-state battery involves almost no trade-offs, a dream scenario for both battery engineers and consumers. In practice, however, the biggest challenge lies in mass production. Manufacturing batteries with high consistency, low defect rates, and costs competitive with today's lithium-ion batteries remains an extremely difficult problem. It is against this backdrop that the solid-state battery technology from Donut Lab has attracted widespread attention from the international media. What truly sets Donut Lab apart from many other solid-state battery announcements is not the technological promise itself, but the speed of real-world deployment. While most major battery manufacturers believe solid-state batteries are unlikely to be commercially ready before the end of this decade, Donut Lab claims its technology will be put into use within just a few weeks. According to Verge Motorcycles, TS Pro models equipped with Donut Lab's fully solid-state batteries will begin delivery to customers in the US and Europe later this quarter. According to a hypothesis put forward by electric vehicle expert Lacey Schmidtka, the abundant material used by Donut Lab is most likely sodium. She cites research by Bella Buscuda, chief scientist at Nordic Nano, involving titanium dioxide nanostructures and carbon nanotubes. These structures are believed to be capable of suppressing dendrite formation, sharp metallic spikes that can pierce the electrolyte and cause battery failure. Based on officially released and widely circulated reports, it is highly likely that Donut Lab is developing an anode-free sodium metal battery, rather than a lithium metal anode design favored by US battery startups such as QuantumScape and Factorial Energy. Sodium has a clear advantage over lithium in terms of abundance, but it still lacks a mature and optimized supply chain, an important factor when considering large-scale manufacturing. If Donut Lab has truly achieved the technological breakthrough it claims, this could open a new chapter for the battery industry and draw greater attention to Europe, a region that is becoming increasingly dependent on battery manufacturers from China, which have been aggressively expanding their market presence there. Conversely, if the technology falls short of expectations, Donut Lab may end up joining the long list of startups that made bold promises but ultimately failed to deliver. The positive news is that the engineering community won't have to wait for years to get an answer. Within just a few weeks, when experts begin tearing down and directly analyzing the battery pack, we will know whether this solid-state battery technology truly performs as advertised. So, finally, this is an interesting new test. While seemingly underwhelming, seeing these operating temperatures and performances lends more credibility to Donut Lab. Likely next week we'll see a low-temp test. For sure they will leave the battery life and density for much later videos, if they'll give proof at all. Bloomberg NEF forecasts that more than 80% of the world's solid-state battery manufacturing capacity will be concentrated in China in the coming years, and the country is therefore expected to take the lead in developing this technology. It is hard to believe that a small company in Finland could have quietly solved the solid-state battery challenge while heavily funded giants, after spending billions of dollars on research and development, have yet to achieve anything close to these KPIs. Yeah, extraordinary claims require extraordinary evidence. In the case of Donut Lab, this principle is not merely a cautionary phrase. It is the only filter separating an energy revolution from a technological mirage. When Donut Lab claims to possess a lithium-free battery with an energy density of 400 watt-hours per kilogram, a 5-minute charging time, and a lifespan of up to 100,000 cycles, it is challenging nearly every physical and chemical limit that humanity has painstakingly established over decades. This is an extraordinary claim because it simultaneously resolves all the major bottlenecks of the electric vehicle industry. However, the evidence available so far remains merely promising, not yet extraordinary. A report from VTT showing stable battery operation at 100 degrees Celsius is a positive signal, but it is not sufficient to substantiate an energy density of 400 watt-hours per kilogram or a lifespan of 100,000 cycles. Why? Because in science, transparency must scale with the boldness of the claim. Forgetting to disclose the cell's weight or avoiding high-temperature charging tests is like a magician asking the audience not to look at the left hand while the right hand performs the trick. That said, history is lousy with cases of small teams stumbling upon game-changing innovations. So, we're staying open-minded on these guys. Donut Lab has definitely piqued our interest, but until we see that cell placed on a scale and surviving a minus 30 degrees Celsius frost test, the jury is still out. What's your take? Is this the end of the lithium era or just another hype cycle? Let us know in the comments below. We'll be jumping in to discuss the chemistry with you. If you found this deep dive helpful, hit that like button and subscribe to stay updated on the next VTT test results. Goodbye, and see you in the next one.